And okay. Hi, everyone. Today we're going to be going over the some more trig laws, so SohCahToa, and then we're going to go over the quadratic formula and just graphing quadratics later. So first, we're going to start off with this acronym that most of us haven't heard before, called SohCahToa. So this is for calculating in right triangles only. This part is important. So right triangles only. And sorry if my handwriting is a little bad today. It's a new mouse pad. But so we have three kinds of values that we can find using SohCahToa. We have, we have sine, theta. Theta is just any angle value. And then just like a x as a variable, theta acts as the same thing. There's a cosine that we can abbreviate as cos, and then a tangent, which is just TAN. So looking back at this SohCahToa, we have S, that stands for sine, O, which stands for opposite. We'll go over what these mean later, but for now, I'm just going to write it out. So opposite over an H is going to mean hypotenuse. So we're going to abbreviate this by just saying HYP. For cosine, it's this A, or the C stands for cosine. A stands for adjacent. We're going to call it ADG. And then H again, which we know is hypotenuse. And then tangent is O over A, which is opposite over adjacent. So let's look at this, this triangle here for some examples on what these opposite adjacent things mean. So I have a triangle here. I have, let me use red. I have an angle here, like I said, theta, just any angle. So opposite and adjacent refers to the sides relative to the theta angle. So since I have my theta angle here, the opposite will be opposite to that theta angle, which is this side over here. So this side that I'm now highlighting red. And then the adjacent angle, as you can guess, is the side adjacent to the theta. So here. And you might be wondering, well, this side over here is also adjacent to the theta. Why isn't that adjacent? That's because in all right triangles, the side that's opposite to the 90-degree angle, which is this symbol over here, is always the hypotenuse. So this will like forever be the hypotenuse. We never call it the opposite or the adjacent or anything like that. It stays the hypotenuse. So this side we can call, like we said, the hypotenuse. And changing it up a little bit, if I were to, sorry, give me a second. If I were to have my theta on this side of the triangle, this angle, my opposite and adjacent would now be switched. So now the side opposite to the theta is the one on the bottom, and the one that is adjacent is the one on the right. So this is going to be opposite, and this is going to be adjacent. And like I said, hypotenuse stays the same. So let's do some examples to kind of experiment with SohCahToa. So I have a right triangle here. I have a side length x that I'm trying to figure out. I have a angle over here, 78 degrees. And then I have a side length here, 18. So the angle we're given, besides the right angle here, which we know is 90 degrees, is 78 degrees. So that's going to be our theta. And then the side length we're trying to figure out here, we have to kind of find the relationships ourselves, is the x. So what is the x? Is it the opposite or is it the adjacent of the 78-degree angle? It's the opposite. So we know we're going to use opposite in some form. And here, this 18 is opposite of the right angle in this right triangle. So we know it's the hypotenuse. So we're never going to use the opposite. We're never going to use the hypotenuse. So which of the SohCahToa values uses opposite and hypotenuse? You can see this sine value uses it. So we're going to essentially plug in the values. So sine theta is just sine of 78 degrees equals opposite, which we said was x, over 18, which is our hypotenuse. And you guys can use a calculator for this because 78 is quite a, you know, exact angle. And give me a second because I need to change my calculator mode to degrees mode. Okay. Okay, so I have sine and I have 78. That gives me 0.978, so I'm going to round it to 0.98 equals x over 18. We're going to multiply 18 on each side, and we're going to get x equals 0.98 times 18, which gives us 17.606, so 61. So we know this side length is 17.61, whatever the units are. And now let's try this one really quick. So we have an angle here. So besides our 90-degree angle, our theta in this case is going to be 42. So what values do we have? We want to find out what the opposite is, and we are given the hypotenuse here. So we have hypotenuse and we have opposite. So plugging in the values again, we know that this is also a sine value. So sine of 42 equals opposite, which is x, over hypotenuse, which is 16. Same calculator program, sine 42 equals 0.669. So I'll say 0.67 equals x over 16. Multiply 16 on both sides, and you're going to get 10.706, so 71 equals x. And that is it for SohCahToa.
Okay, nice. So I guess it's my turn.
Mm-hmm.
Okay. Wait, so your screen recording, right?
Yes, I am still recording.
All right, so that was SohCahToa, and now we're going to move on to quadratics, and specifically how to graph quadratic equations easily. So as you guys already know, quadratic equations are in this form: y equals ax squared plus bx plus c, or at least you can put them in this form. And graphing them can be a pretty tedious process. You guys probably know they look like a parabola, but it's kind of hard to figure out how exactly that parabola looks. And you could just try different values of x and y and then just go from there. But there's a quicker process, and that is first to find the x-intercepts of the parabola, so where it intersects the x-axis. Although not all parabolas have these, but a lot that you encounter will. And then the second step is to find the y-intercept of a parabola, and all parabolas will have a y-intercept. And then you can use that to graph the equation. So now the first question is, well, how do we find the x-intercepts? And the two main ways are, one is to use the quadratic formula, which is this formula, negative b plus or minus root b squared minus 40c over 2a. And it looks kind of complicated, but it's not too complicated. You just take the a, b, and c numbers from here, and you plug them into this formula, and you will get, because of this plus or minus, one of the roots will be plus, the other will be minus. So that's how we find the x-intercepts. Or we can use this property. And the property is that when a product is equal to 0, then at least one of the factors must be 0. It's called a zero-sum property. So basically, if you have, so this is kind of easy to think about. If you have an equation where a times b is equal to 0, where a times b are any kind of variables, then we know that either a must be 0 or b must be 0, or maybe both of them are 0. And we can use this to solve quadratics. Because some quadratic expressions can be factored into the product of two simple binomials. So when we solve for x equals 0, or for the x-intercept, that means y equals 0. So once we do 0 is equal to ax squared plus bx plus c, we might be able to factor this. So let's look at an example. So the first problem is determine the x-intercepts of the parabola y equals x squared plus 6x plus 8, and then find the y-intercept and sketch the parabola. So first, let's do the x-intercepts, and let's see if we can factor this to be the multiplying of two things. So we know it's going to be y is equal to, let me delete that dot. We know it's going to be y equals like x, uh, basically x minus or plus something times x minus or plus something because we have x squared here. And a trick I like to use when it's just x squared is you're trying to find two numbers that multiply to the third number and add to the second number. So in this case, 4 and 2 works. So we know that it's y equals x plus 4 times x plus 2. And just a quick sanity check to make sure this works. If we factor this out, we're going to get x squared plus 2x plus 4x plus 8, and that will end up simplifying to x squared plus 6x plus 8. So this does work. So now for which values is this 0? So 0 is equal to x plus 4, because we're trying to find y equals 0, because the x-intercepts are when y equals 0 on this line. So it's 0 when x equals -4, obviously, because -4 plus 4 is 0, so the whole thing ends up being 0. And it's also 0 when x equals -2. So now we have our x-intercept. So we know that there's a point at -4, and there's a point at -2. Now for the y-intercept, we use a similar process, except the y-intercept is where x equals 0, not y. So if we plug in x equals 0, we just get a simple answer, which is y equals 8. So we know that there must be an x-intercept at 8. And now we can graph this parabola pretty easily. It's going to look something like this. And let me actually draw that a bit better. Something like that. Yeah, so that was our answer. Because it says sketch, it doesn't have to be exact. So now let's go to the next question. And this time it is use the x-intercepts and the vertex to sketch the graph. So the vertex of the parabola is the point where it goes from increasing to decreasing or decreasing to increase. So it's kind of like if we go back to the first graph, this would be the vertex. It's kind of like it's basically the point where the parabola switches. So if we have like a parabola right here, this would be the vertex. Or if we have a parabola like this would be the vertex. And we can obviously use that to sketch it, because if we knew where it was, it'd be kind of easy to tell how the parabola looks. So first, let's try to factor this. Now, it's kind of hard to factor these kind of equations. So in this case, I would probably end up using the quadratic formula, but for the sake of this lesson, let's try to factor it. So we know it's going to be either -2x plus something times x plus something, or -x times something times 2x plus something, because we have this -2x squared, so we know that we must have these terms. So now what we can do is we can try different numbers. The rule remains that the two numbers that we pick to be in these factors must still multiply to 15, because once you kind of distribute it out and you multiply them out, the only term without the x would be those two numbers, so they must multiply to 15. We can try different numbers here. I suggest we try maybe 5 and 3, because those multiply to 15. And let's try maybe x plus 3, maybe -2x plus 5. I don't know if this is the answer, but it seems like we're going to have -6x from here plus 5x. Doesn't mean -x, but we want 7x, so that doesn't work. Let's try maybe because we have that doesn't seem to work, we can try two negative numbers, so maybe -5, -3, because that also multiplies to 15. So now what do we have? Well, we have plus 10x here and then minus 3x here. So this does seem to work. So we did factor it. And you can see how that process can be a little confusing. So in that case, to find the x-intercepts, I would recommend just using the quadratic formula, but we didn't have to this time. So now when is this 0? When x is 5, it's 0, because this factor is 0 when x is 5. X minus 5 is 0, so y must be 0. And then the other one is when x is -3/2. And why is that true? Well, when that's the case, then -2x is -3. 3, and 3 minus 3 is 0, right? So this is 0 when x is -3/2. So now let's graph that, or at least graph these 2 points. So we know it's going to be here and somewhere here. And now to find the vertex is actually going to be right in the middle between the two x-intercepts. So to find the middle, we just do 5. So we find our average, right? 5 plus -3/2 over 2, which is just going to be 3.5 over 2, which is just going to be 1.75. And now we can use a calculator to see what y is when x is 1.75, since we know the x corner of the vertex. And it turns out that y is actually 21.25. So the point will be 21.25. So that's somewhere up there, so we can maybe just put a point there. And we know that the graph, or at least not there, but has to be in the middle. And we know that the graph's going to be facing down because we have the vertex above the x-intercept, so we can it's kind of a bad drawing, but the graph will look something like this. So that's our graph. So now let's go to the last 3 questions, and these are basically just practicing factoring these kind of numbers. So our first one is x squared plus x minus 20. Now this one's easier because for this one we can use the property I talked about at the start, where we have 2 numbers which add up to this number but multiply to this number. Now the 2 numbers are, you kind of get better at this with practice, but it's +5 and -4, right? Because 5 times -4 multiplies to -20, and x plus 5, +5 minus 4 adds up to 1. So we know that the x's when this is 0 are going to be -5 and 4. Now for the second one and third one, I suggest we try using the formula. So if you guys remember, it's -b plus or minus root b squared minus 4ac over 2a. So -b is going to be -11. So the second number is b. -11 plus or minus root b squared is 121. Now 4 times a times c is going to be 10 times 3 times 4, which is 120. And then everything's divided by 2a, so divided by 6. Now 121 minus 120 is just 1, and root 1 is 1. So we have -11 plus or minus 1 over 6. So for one of them, that's going to be -11 plus 1, so -10 over 6. -10 over 6, or x is equal to -12 over 6, -2. Now the third one, let's try factoring it again. So for the third one, maybe using the formula would be easier, but let's try factoring. So we can try factoring is almost guess and check, but I suggest we try maybe 3x plus something times 2x plus something. Now the only thing that doesn't change is that the 2 numbers have to multiply to -15. So maybe we try 2x. So this number, how many 3x's we have? So maybe we try -3. Or maybe we try let's do 3. And then +2. Or +5, right? So that almost works because we have -9x and plus x. This actually ends up being 6x squared plus x minus 15. So that's not what we need. Let's try different numbers. It doesn't seem like 2x and 3x will work. So maybe we try 6x and x. So maybe we do 6x. Wait, can you give me a second? I gotta.
You're good.
Yeah. Okay. My brother was just mad for no reason.
Your brother sounds so cute. I'm sure what he was doing just now wasn't cute, but he sounds so cute.
Okay, wait. I think for this one, let me go back. You might have to cut out.
Don't worry about it. I'll cut it out.
I think it's 3x and 2x, but it must be plus 3 minus 5. Oh, okay, that's what it is. Okay.
Yeah.
All right, let me finish real quick.
Okay.
All right, so the two numbers that do seem to work are going to be 2x plus 3 and then 3x minus 5. Oh. So now we know that the x's, so this is going to multiply out to this. And the x that we're going to get that make it 0 are x equals 5 over 3, because then 3x minus 5 is 0. And also x equals negative 3 over 2, because then 2x plus 3 is 0. So these are the two answers. And okay, that's pretty much it. So all I have. So just to summarize, when you graph one of these equations, you find the x-intercept using either the formula or the zero-sum property, and then you can either find the y-intercept or the vertex to graph it easily.